All right. Okay, so in the last lecture, we have seen the decoders actually. Yeah? And I introduced a new input in the decoder, that was the enable input. Do you remember that? And with that, if I want you to write a Boolean function for this decoder, can you help me here? This is the input of a 2x4 decoder, and you will be having 4 outputs here, that is y0, y1, y2, y3. And if I say there is an enable input here, so according to that, this y0 will be what? E into, let's suppose this is x and y. For the simplicity, I am taking x as an input at I0 and y as an input at I1. So the Boolean function for this y0 will be what? X bar y bar, E into x bar y bar, isn't it? And similarly, this will be what? E x bar y. This will be E x y bar, and this will be E into x into y. So this was the Boolean expression for each of these outputs for the 2x4 decoder. Now today what we will do, we will implement higher order decoders decoder implementation using the lower order decoders. When I say higher order decoder, it means that you have this 2x4 decoder here, and I want to implement 4x16 decoder. So the question is, implement 4x16 decoder using 2x4 decoder. So here the required module is higher order than this the given module, isn't it? So you want to implement this 4x16 decoder using 2x4 decoder. So is it possible to implement it? Yes, it is possible. So how will it be proceeding? So we will see first what are the outputs for the required or the given question given in the what is the required module in the given question, correct? So here we have 4x16 decoder, and the output of this decoder is 16, and we have the ICs available, that is 2x4 decoder with outputs 4. So minimum number of decoder, how many you will need? No, that is the exact answer, but at least to generate 16 output with this 2x4 decoder, at least minimum number of ICs you will be needing 4, because at the output you need 16 outputs here, this side, correct? But to operate this, we will be needing another one. That's why the correct answer is 5. And how will you obtain the exact number? How many ICs of 2x4 decoder will be needed to implement 4x16? So there is a process. You will first write the outputs of the required IC and divide it by the outputs of the given IC. So the solution will be 4, and again you will take this 4 here and divide by the given IC's output. So it will be 1. So and you will add this. So the answer will be 5. So this 5 ICs of 2x4 decoder will be needed to implement 4x16 decoder. Okay, now I will quickly write down the 4x16, the truth table for 4 variables to understand this implementation. So we have, let's suppose we have here A, B, C, and D. These are 4 variables at the input of this decoder. So what are the possible combinations here? This will be the combination 0, 1, sorry, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1 0, then 1 1, then 1 0 0, and 1 0 1, 0 1 1 0, 1 1 1 0, then 1 0 0 0, 1 0 0 1, 1 0 1 0, 1 0 1 1 1 0. So see this pattern. Here you have this C and D, which are these two variables, and if you can see here, these are repeating after four combinations. After each four combinations, here you have 0 0 0 1 1 0. Again you have this similar pattern you have. So can we add here the input of these four ICs, that is 2x4 decoder? So the input will be C and D for this last four ICs of 2x4 decoder. Correct. So Y0 will be what here? C bar, D bar, isn't it? The similar case for this IC, second IC. Here also this Y0, let me call this Y4. So Y4 will be what? C bar, D bar. Similarly, here you will have Y8, this will be C bar, D bar. And I'm calling this as a Y12, that is C bar, D bar. Correct. So I have defined this first minterm, this fourth minterm, and 8th and 12th minterm. And all of this will be C bar, D bar here, Y0. Y1 will be what? This 0, 1, then again 1, 0, 1, 1. So we have implemented this half part of this truth table. Now what we want to do, we want to select each of this IC based on the variables A and B. When should this enable? When should this first IC should enable? I have implemented C and D. So look for this first part here. If we divide this whole truth table in four parts, so first part will be enabled when A and B are 0, 0. So can I take another IC here that produces 0, 0? That means A bar and B bar. And if I will connect it to the enable input of the first IC, so the total or the combined Boolean function at Y0 will be what? If I have an enable, so I will be writing this Boolean function as this. And E is what here? E is A bar and B bar. E is A bar and B bar. So this Y0 will be now A bar, B bar, C bar, D bar. That is generating first minterm for four variables. Right? So now my job is that I should have one output here, that is A bar and B bar. And when it will be, when I connect the inputs of this 2x4 decoder as A and B. So this first output of this IC 2x4 decoder will be A bar and B bar. Second output of this IC will be what? A bar, B. And that exactly we want to enable this part, A bar, B. So we connect this second output of the first IC into the enable input of this IC. In this way, we can implement 4x16 decoder using 5 2x4 decoders. Is it clear? So now we will move on and we will implement 3x8 decoder using 2x4 decoder. So now answer me, how many ICs of 2x4 decoder will be needed? The answer, the obvious answer is 3, but it is not correct. It is not correct actually. And by procedure, if you will follow, so output of the required IC is 8. And the output of the given IC is 4. So you will divide this and you will obtain 2. Again, you will take this 2 here and divide by 4. So you will be having half. And there is no available ICs with this form. Correct? So here you will use this enable input. Enable input. If you are smart enough, then you can answer with this enable input. Now, half of the job is completed here. See, for 3x8 decoder, you will be having this truth table. So these two boxes are same. So you need 2 ICs to generate this 2x4 decoder. You can implement this minterms. But for the first block, there is a variable that is A, B, C. Let me call this A and B and C. So A is 0. So I will be using this NOT gate in front of the enable input of the first IC. So you have 2 inputs, that is B and C here, and enable is connected to a NOT gate, and this is my A now. So this circuit or this combination will implement half of this truth table. Now again I will take the second decoder of 2x4 decoder, and the same B and C will be connected here, and enable will be this A. So this circuit, this combination will implement 3x8 decoder. Is it easy? Okay. You can check for anything, means this is your Y0, Y1, Y2, Y3, this is Y4, Y5, Y6, and Y7. So let me check for this 1, 1, 0. So A is 1, B is 1, and C is 0. So when A is 1, it means this IC, whole IC will not be working. The output of all this will be 0. Only this IC will be enabled for A equal to 1. And now we'll check for B and C. So B is 1, C is 0. 1 and 0. That means this is that second minterm. Third min, sorry, 0, 1, 1, 0, 0, 0, 0, 1, and 1, 0. So this Y6. So 6 will be implemented if we give the input as a 1, 1, 0. Okay. So now can you implement 5x32 using 3x8 decoder? The question is implement or realize 5x32 decoder using 3x8 decoder. How many ICs of 3x8 decoder will be required to implement this? So we'll do this 32 by 8 will be 4, and then again there is a problem. So 4 ICs of this, and there may be some other logic circuit, this gates that they are, if NOT gate is required, then there will be NOT gate or OR gate may be required. So you need to think about it. And how will you proceed? You will first write the truth table for the 5 variables. I think now it is very easy to write. Can you do or not? You need some help. I think it is very easy because there is a pattern. Just you need to 0, 0, 0, 1, 1, 0, 1, 1, and then You have to follow this. Correct? Okay, now. So this way we implement the higher order decoder using the lower order decoders. Now we will solve one question. I will give you one function, Boolean function. F, there is a 4 variable a, b, c, d, and which is given in this form: a bar b plus c bar d plus b c d bar. So you need to implement this Boolean function. The question is implement this Boolean function using decoder. Implement this Boolean function using decoder. So first of all, you should think about what are the variables, the number of variables. There are 4 number of variables. So you need 4 cross 16, this IC, 4 cross 16 decoder. Right? So should I solve this, or you can solve this? Is it easy? First of all, you should know what are the min terms this term is connected with. For which min terms, for what min terms this a and b is holding. So how do you proceed? You can see a bar b here and c and d are absent. It means that these are fixed. A bar is 0 here and this is 1. Now CD will be having 4 combinations. So 0, 0, 0, 1, 1, 0 and 1, 1. And this will be same. A bar and B will be same. Now what is this? This is 4, 5, 6 and 7. The similar way you will write for this C bar and D. And here A and B are absent. So A and B will be having the 4 combinations: 0, 1, 1, 0, 1, 0, 1, 0, 0, 0, 0, 1, 1, 0 and 1, 1. And C bar is 0, D is 1. So now this is the 1, first min term, this is 5th min term, 9 and 8, 12, 13. Here B, C, D bar. B, C, D bar, A is absent, so A will be 0 and 1. A can be 0 and 1. And B, C, D bar will be 0. We will write according to this min term. What will it be? B will be 1, C will be 1 and D will be 0. So 1, 1, 0. And this is what? This is 6. And here 6 plus 8, it is 14. So now you have all these min terms. I can write this A, B, C, D, F as summation M. These are the min terms, which is 1, 4, 5, 6, 7, 9, 13 and 14. Now it is very easy. You need just only one OR gate and connect all these outputs that are the min terms of a decoder. And you can implement it. Now the question is that if this is the question given and you need to solve or you need to implement this Boolean function using 3x8 decoder. It is very easy to implement this using 4x8 decoder. But can you implement this Boolean function using 3x8 decoder? I think there should not be any hurdle. Just only one thing is needed, that you should care about the enable input. 3x8 decoder means we'll be having the least 3 variable at the input of 3x8 decoder, that are B, C, D and D. This is your 3x8 decoder. You will be having here 8 outputs. According to that, what are that? 0, 0, 0, it means B bar, C bar, and D bar. Here B, C, D. Here it is 1, 1, 1. So we have implemented 0 to 7 min terms here using one 3x8 IC. But what about this 8 to 15 min terms? You need another IC of 3x8 decoder. We will be having another IC of 3x8 decoder. And these inputs are connected as B, C, and D. And these are connected like this, B, C, and D. And at the enable, here we'll put a NOT gate in front of this first IC, and that is connected to variable A. So now when A is 0, it means all these 7 min terms will be implemented. When A is 1, this rest of this 8 min terms will be implemented when A is 0, and when A is 1, the rest of 8 min terms will be implemented. So I just asked this question, realize 5x32 decoder using 3x8 decoder. So absolutely there is 4 3x8 decoder ICs, but to enable all these 4 ICs, you need one 2x4 decoder. So here two variable A, B, and here B, C, D, and E. These are 5 variables. So 5x32. So all these 3 C, D, and E will be connected to each of these decoders. So this way you can implement 5x32 using 4 ICs of 3x8 and one IC of 2x4 decoder. Just you need to think, how can you enable these ICs? These are implementing 7 min terms, 8 min terms from 0 to 7, this from 8 to 15, and then next. And all things can be done using this truth table. So now a very simple question, if anyone can answer me. You have 2x4 decoder here. This is the information given in the question, only this is the information. And they said that which type of gate this IC is implementing. The answer should be which type of gate. No. Someone said the right answer from their home. Who is this?
Samarth.
Is it AND gate, OR gate, or XOR gate? Or there may be so many options. So correct answer is XOR gate. If here X and Y are the inputs of this decoder, so this will be what? X bar Y, and this will be Y bar X, or X Y bar. So F will be what? The output of this OR gate will be X bar Y plus X Y bar. That is XOR gate. So this type of questions comes everywhere in your competitive exam. Okay, so here we have completed the implementation of higher order decoder using the lower order decoder. Also, we have seen that how can we implement a Boolean function using the decoders. Now, 1 or 2 things are remaining in this decoder, and then I will jump to the multiplexers. Till now, you have seen how to implement SOP form. This is SOP form, isn't it? Sum of product. But when the question comes about this POS form, then what will you do? Here for SOP form, you need IC and one OR gate. Here you are generating this. This is in the form of SOP. But if they ask to generate a POS form, then which type of gate will be required? Think about it. I will give you 1 minute, then I will be showing how can we implement POS using the decoders. I need one answer. If they say the question is that realize this function a, b, and c, which is having 3 variables and given in this form, summation seven. So in SOP form also and POS form also, using a 3 cross, using realize this function using 3 cross 8 decoder IC. So it is very easy when this is in the form of SOP. You solve so many questions. You need just one OR gate and one IC of 3 cross 8 decoder. So here this is Y0, that is implementing first minterm. So I can write as M1, M2, M3, M4, M5, M6, M7, M2, M3. No, this will be M0. It should be M0. So let me take another input here, output here. That is M0, M1, M2, M3, M4, M5, M6, and M7. 3 cross 8 decoder. A, B, and C. So now to implement this, you need just one OR gate here. You will connect it with the minterms, first minterm, second minterm, sixth minterm, and seventh minterm. Here your F is available. But what about the POS form? So what will be the POS of this function? The remaining terms? Yes. So F will be, in the POS form, can be written as pi capital M. So what it will be? 0, 3, 5, 4 also. Yes. Now think about the gate. Which gate will be required to implement instead of this OR gate? 4 and 5. So if I put here a NOR gate, will it do the job? No idea. Yes, it will do the job. Means it will implement the POS form. Fourth and fifth. How it will do? I will show this by using a 2 cross 4 decoder. Here you have X and Y and 4 output. These are X bar, Y bar, X bar Y, X, Y bar, and X and Y. So now I want to implement this POS form. It means POS, how it will look like? F, X and Y will be what? X plus Y bar into X plus Y. So this is X plus X bar Y, X bar plus Y bar and X plus Y. Which minterm is this? Which minterm is this? Means
Third, sir.
Not minterm, it should be max term. Which max term is this?
3, sir.
Yes, it will be 3 and this will be 0. Remember this. Okay, so now if I will connect here one OR gate. So at the output of OR gate, x bar, y bar plus xy whole bar, isn't it? So now how will you solve using De Morgan's theorem? You'll be having x bar, y bar whole bar into x, y whole bar. And now you can write this as x bar y into x bar plus y bar. And this is the same as this. A similar way, this OR gate will implement the POS of this. I think this is clear. Let me check if anything is remaining in decoder part. So I have shown you that how to implement the full adder using decoder. Full adder. You will be having two outputs of full adder, means sum and carry. Sum will be having 4 minterms and carry also have few minterms. You need, at the end, you need 2 OR gates. Okay. So this is the homework. You need to implement subtractor and half adder circuit using the decoder. Okay, so implementation using 2x4 decoder or any ICs of decoder for the Boolean function we have seen here. Now we'll jump on the multiplexers. Okay, what are the multiplexers? Multiplexer is also an IC, is also a combination logic circuit that actually selects one input out of many inputs and reflect that input at the output. I will repeat this. Multiplexer is a combinational circuit that select one input out of many inputs and reflect or direct that input to the output. So you will be having only one output at the output of multiplexer. This is multiplexer. And we represent this multiplexer as MUX, MUX. So there may be many inputs. These are the inputs. And you will be having only one output. So you should think, how can we choose one input and be reflecting that input into the output? So there should be a mechanism to choose that input. Okay, so there will be selection lines. So we call this bunch of buses as selection line, select line or selection lines, selectors. The representation of MUX can be given like this. In few books, they represent MUX as this. So these selection lines, I am showing the basic MUX IC, that is 2x1 MUX. So to select two inputs that are I0 and I1, I should have one selection line, and we are defining this as a S0 or S, you can call it S, and here you will be having the output. So let me define this output as Y. So when S is equal to 0, whatever the information inside this I0, this will reflect to the output. When S equal to 1, whatever the information inside this I1, this will be going to the output. So how do you write the Boolean function for, or Boolean expression for this output? S bar I0 plus S into I1. So in the similar way, we are having 4x1 IC, 4x1 mux multiplexer. So here you have 4 inputs. It is I0, I1, I2, and I3. And to select this 4 combination, we need few selection lines. Correct? So these selection lines are related. The number of inputs, if let me call this number of input is n, and the number of selection lines are m. So m is log. How can you write? Means n will be what? 2 power m. That's it. So what will be the m? Log n base 2. Correct. So for the 4x1 mux, you should be having here 2 selection lines, isn't it? Then only you can select one of this for the definite combination of the selection lines. And when you study this selection or solve the question for these mux problems, you always be focused on this selection lines. If you change the polarity, means this it is, I am defining this as a LSB and this is a MSB. So if you change the polarity, all these inputs selection will be different. Okay. So now for this 4x1 multiplexer, can you write the function, Boolean function for the output of this multiplexer? How can you write? There are also this enable input always present in the ICs, because if you don't want that IC to work in the circuit, you are not pulling up and plugging it. So always you have one enable input in the IC, so that you can perform that, you can give the input as 0 or 1, so that will work or not. Why will be? Yes, it is very easy. I will just write it. Zero, zero, I1 will be selected. I0 will be selected. For 0, 1, I1 will be selected. 1, 0, I2 will be selected. And 1, 1, I3 will be selected. And if there is an enable input, so enable should be high for all this combination. And if it is 0, so whatever the condition of this S1 and S0, the output will be 0. So this will become don't care stages. So in this way, you can write Y as E into S0, that is S1 bar S0 bar I0 plus E, that is enable input S1 bar S0 into I1 plus E into S1 S0 bar I2 S1 S0 I3. So if your selection line here is connected to 1 and 0, let me take an example here. This is connected to 1 and 0. It means that 1 and 0, S1 is 1, S0 is 0. So here I have written something. No. This part will be high only, and except this E, S1 and S0 bar I2, all will be 0. You can check it. So at the output, you will be having only E into I2. And if E is 1, so the output is what? I2. That's why this mux selects one of the input from the combination of inputs, and it reflects to the output. Now answer me, I have an IC here of 4x1 mux multiplexer, and these are connected to 1. Here selection lines, I have X and Y. So which type of gate this IC is implementing? These are connected to 0 and 0. The middle two inputs are connected to 1. These are high. And
Sir,
here
वो
at the selection
दिख
line.
नहीं रहा, आप थोड़ा साइड में बना दो.
Okay. So this line, can you see?
Yes, sir.
Okay. The question is, if you want to implement, not implement, the question given like this. The middle of these two inputs are connected to 1, and this is 0. So what will be the output? Which type of gate this 4x1 mux is implementing? XOR. Exactly. So here you have an idea how to implement XOR gate. It means you can implement any minterm, isn't it? What you did here, you have implemented this X bar Y plus X Y bar. So now if someone says that with the two variables, implement this Boolean function, can you implement it? Yes, it is very easy. You need just to take care about the selection lines, and you will assign these selection lines as a variable, and whatever according to the min terms, what will be the condition or what will be the input of this mux. Okay. Now we'll see the implementation of Boolean functions using this mux also. Earlier we have implemented Boolean functions using decoder IC. I have given a glimpse of this two variables Boolean function. So now can you implement a 3 variable Boolean function using a mux? That will be the question. Okay, think about it. I'm writing the question. Okay, before that, please answer this question. You have a 4x1 multiplexer IC. Here I0, I1, I2, I0, I1, I2, and I3. Let me check with the question, otherwise the answer will be different. This is C and this is A and B. Now the question is which type of gate this is implementing and what will be the solution actually. Is it A nor B, A nor C, or yes, try to solve it. I'm giving the options. Okay, so how do you proceed? Okay, solve it for 1 minute, then I will solve it. This Boolean function for this output is given here. Forget about this enable input. Everything is given, S1, S0, and I0. So this type of question comes into the examination. If you think about the gate point of view, so they will give only 1 or 2 minutes. You need to solve it. A XOR C, the third one. Okay, we will check it. One answer we obtained, A XOR C. Second answer.
A XOR C.
Okay, so we have majority on the A XOR C, and that is the correct answer. So I'm not going to solve this because it is very easy. Okay. Okay, now we will implement full adder using this 4x1 mux. As of now, it is some of you will facing some difficulty, because you need to, first of all, you need two multiplexers, because you need to generate sum and carry, and for one multiplexer IC you have only one output. Okay. Okay, so can anyone tell me what are the mean terms for the sum of full adder? A, B, and C. And C, I assume this C is C in. Okay. So what are the mean terms? Okay. Summation 1, 2, and what? 4, 7. Okay, yes. Remember this, whenever there are odd number of ones in the combination, that will generate the sum. Because for 1, 0, 0, 1, 2, 0, 1, 0, for 4, 1, 0, 0, and for 7, 3 ones. And what are the carry? This is what? Please take other student, otherwise we will be solving the wrong question. 3, 5, 6, 7. Okay, now so I have given an idea here. You need to take two of the variables as an input at the selection line. Okay. So we will decide. I think this part is not visible to students. So now I will write here a K-map in vertical form. I think you are seeing this as first time. For three variable, we have A, B, and C here. So this is 0, 0, 0, 1, 1, 1, and 1, 0. This is 0, 1. So for this sum, do you have any lecture after this 3? Okay, no problem. So for the sum, we have this 1, 2, 4, 7 minterms here. So this is 0, 1, 2, 4, and 7. Okay. So now if I decide this mux is having 4 inputs and 2 selection lines, as S1 and S0, and if I connect this S1 as A and S0 as B, so for this combination 0, 0, this will be selected. Okay, for 0, 0, this will be selected. So for this 0, 0, this cell is active and this is giving the answer of I0. We are not solving the K-map here. We already have the minterms. We want to generate some logic here. So this cell will give you the I0, and this cell will give you the I1. So here, what is the minterm here? And it is active for C. So this will be connected to C. Now see, if 0, 0 at the selection lines, so first output, in this way, how can you write? F or Y, whatever it is. So if E is 1, enable active high, this IC is active high. So for A, B, and this C, so A bar, B bar, and C, and which is representing your first minterm. Isn't it? Now second, for I1, what should be connected? C bar. And for this I2, we should connect this I2 as a C. So we can extend this line and we can connect like this. And here for I3, again we will connect to C bar. So this will be connected to C bar. So in this way, you can implement this summation part of this full adder. So now can you implement this carry part using 4x1 mux IC? It is easy. But you need to take care about this K-map. You can also choose another variables as a selection lines. Let me choose this. If I draw this horizontally, so I have B and C here, A and B, A on this side. So now 0, 0, 0, 1, 1, 1, 1, and 1, 0. So if I choose this BC as a selector, so this cell will be the output input. This cell will select the input of I0. Now I will populate this sum function here. So this will be 0, 1, 2, 4, 7. So again, we need to connect at I0 as 1. So now the mux will be different than this. Now you will be having the second mux or another mux. You can select any variables at the selection lines. You can connect any variables for the given function as a selection lines, and the remaining will be the input of that mux to implement this Boolean function. So now we were solving with selection with this A and B as a selection lines. So assume here, you should write, assume in the answer also, whenever you are writing the university exam or this institute exam, you should mention which type of assumption you have made. So I will quickly solve for the carry and then we'll conclude this lecture. For the carry part, you have 4x1 IC. These are the 4 inputs, I0, I1, I2, and I3. And here you have selected S1 as A and S0 as B. And this is the output of this mux, and it is generating the carry part. Now you have this carry function, and I will populate this K-map AB 0, 0, 0, 1, 1, 1, and 1, 0. This will be 0, 1. Now carry is what? 3, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Correct. Now this cell is associated with the I0. So I0 should be connected now with the 0. Now here this cell is connected to associated with the I1. So this should be connected to C. Now here you have this 2 minterms. Both the cells are high. So now you have, whenever you have both the cells are high, it means that you are solving for C bar plus C. And what is the answer of this? C bar plus C is what? 1. And also you can see, regardless of the condition, always C will be 1. The C is 1, C is high. Means not C, the connection of the correspondence input of this cell will be high, always. So this I2 will be 1. Also you can solve in this way. Again, for the last cell, I3 should be connected to C. So now the second mux, which is generating your carry part, it should be connected to 0, C, 1 and C. So this will implement your carry of this full adder. Okay, so we will conclude this lecture here. I think the next faculty will be waiting.